Hi, this is Akil Kumar Mundoji. Today I'm going to present my presentation on topic application of data mining in sheet metal assembly, dimensional variation diagnosis. Let me tell you what is sheet metal assembly. Sheet in manufacturing industry or in automotive industry, sheet metal plays a vital role. Uh, uh, in order to assemble any of the parts to the body, we use sheet metal. So that we use fixtures or welding equipments to uh, attach the sheet metal to the body. So by using the fixtures and fixtures or welding, there is a dimensional variation which leads to problems. So in this we use data mining techniques in order to overcome that variation. So coming to the introduction part, the dimensional precision of an auto body affects the service quality and performance of the vehicle, as numerous numerously more than 30% of the quality defects of a car are due to dimensional deviation of body in white. Dimensional deviation diagnostic methods can be classified as model-based, signal-based, and knowledge-based methods. Let me tell you what is model-based, signal-based, and knowledge-based. Model-based commonly apply inverse derivation algorithms on a variation transmission model to determine the control variables of a certain dimensional variation. So coming to the signal-based were often adopted if the input and output signal of a system can be fully acquired even though accurate model cannot be provided. So since these signal process methods rely mainly on online inspection, some faults may not be found out if the corresponding machine sensors are not installed. Coming to knowledge-based methods. As for the knowledge-based diagnostic approach, with the aid of product and fixture knowledge, in 1994, it was firstly put forward a diagnostic method including fixture failure pattern modeling and fault matching. Although this method helps engineers to find the failure of a fixture, other process factors such as misoperation and misadjusting are rarely considered. During the period of launching a new car, testing of the assembly process such as fixture parameters, welding parameters, and operating procedures, etc. The dimensional variation can be identified rapidly through integration of product designing, process designing, measuring, and variation analysis model. So in this, the variation causes. So what are the main reasons for this variation causes? As we are seeing the failure of welding fixture, variation of stamping parts, variation of process parameters, misoperation. So let me describe you what are those. Coming to failure of welding fixture. In sheet metal assembly, the assemble precision is determined mainly by the fixtures, and any deviation of a fixture will directly influence the dimension of the product. Coming to variation of stamping parts. Although having been precisely controlled, stamping parts inevitably have dimensional variation because of the uneven material characteristics of sheet metal, the varying of the stamping die, and the variation of the control parameters of the press machine. Usually, variation patterns display apparent differences between batches. Coming to the next, variation of process parameters. Process parameters include static process parameters and dynamic process parameters. Static process parameters are the designed process characteristics, and dynamic process parameters are referred to the changing of locating datum and varying of welding parameters. Coming to the misoperation. Misoperation frequently occurs in the assembly process, especially when there is a need for much manual operation. Okay, coming to the analysis part. So in this, what type of analysis we are using and what are the analysis types we are using in that. So the goal of data mining is to determine the interesting patterns that exist but are hidden in data. We already know that data mining makes use of various analysis tools to find the association and knowledge hiding in the mass data. The measured dimensional data has both spatial and sequential attributes. The data which has to be measured has both the spatial and sequential attributes. The data are measured by coordinate measuring machine, while other subassemblies and parts are usually detected by checking the fixer. As we have seen that the data has to be measured in spatial and sequential attributes. So coming to that next one. So as we can see that in the analysis we are using the clustering type of analysis. So the measured data can be divided into two groups, small variation group and large variation group, SVG and LVG. The degree of similarity among the elements of set U can be explained by similarity matrix. As we are seeing, what is set U? Set U is a collection of small variation group and large variation group of data. And coming to the next one, let covariance of UI, uj be covariance coefficient. Here we can see that R equals to R11 R2. This is a set of similarity matrix which is denoted by I and J, and where I equals to 1 to n and j equals to 1 to n. The similarity ratio can be calculated using the value Rij equals to covariance of ui, uj by sigma I into sigma j, where sigma I and sigma j are the ith and the jth dimensional characteristics. Coming to the next one. In this analysis, a typical multivariable statistical method helps to reveal a simpler pattern from a complex set of variables. Suppose if x equals to x1, x2, x3 up to xp is where p is a decision random variable. The principal component is represented as the linear combination of the origin p variables, where as we can see the previously we have the matrix of a11 a12 to a1n, but here in this we are converted that to a1p, where p is the dimension random variable, and which is transformed to these values like a11 a12 a1p, and the variance of xi can be calculated as bi1 square of variance at 1 plus bi2, etc. Clustering tree analysis. In this clustering tree analysis, each dimension element is defined as a joint point with the similarity degree Rij between element ui and uj is not equal to 0. Then a weighted line is used to connect them. Suppose if we select u7 and u9 and a similarity degree of R79 which is not equals to 0, then a weighted line is used to connect U7 and U9. So the characteristic equation of the variance matrix will be lambda I minus C into whole into B equals to 0, where C is the covariance matrix of X, I is an identity matrix, and lambda is an eigenvalue. The covariance contribution ratio, where C equals to lambda of R by sigma R equals to 1 to P into lambda R. The variance contribution for each principal component is sigma R equals to 1 to K lambda R by sigma R equals to 1 to P lambda R, which is greater than or equals to 85%. Where we can see that here we can see that SVG, LVG, small variation group, large variation group, and these two, the darkly uh, spotted are the clustered groups, where uh, R where K is the accumulation variance contribution. So the sign of the eigenvalue represents the relative direction among the deviation, which means if two eigenvalues have contrary sign, when one dimension deviates to left, the other will deviate to right, and vice versa. Moreover, the absolute value of eigenvalue representing the variation range, the larger the absolute value, the larger will be the corresponding variation. The direction of the arrows indicate the relative deviation direction. So in this we can see that the door outer panel, here the arrow is indicated inwards and the other arrow is indicated outwards. So from this we can say that the direction of the arrow indicates that the deviation effect is outwards. Thus the larger the absolute value of the eigenvalue, the larger will be the corresponding variation. The variation pattern can be denoted by a series of arrows. Failure mode of certain process parameter or fixed characteristic parameter is stored in the fault mode basis. As we can see, these are the parameters which we have to consider for a failure mode. So first goes to the user, then comes the interface, and then the interface is divided into two parts, where knowledge base and measurement base. If it so we have to consider those knowledge base and measurement base. In knowledge base, what are the rule extraction, what are the rules and regulations we have to follow for that, and measurement base, what are the variation for that pattern or variation for that method. So from these rule extraction and variation, when we have to consider what are the reasons for the variation, and next comes evaluation, what we have to do for the variation, and next comes the decision. So what are the decisions we have to take for avoiding variation or something like that. So in this we can see that whether related components have large variation. Yes. If yes, variation causes identification of related components. If no, whether fixture status change. So if the whether fixture status change, yes. Whether man-made adjusting or whether welding parameters being changed. So from that the same way we are going to take that. So in this result, as we have seen that uh, in this clustering tree analysis, it was found that some welding points located at the connection zone between rear end panel and underbody were lost. As we are seeing that rear end panel and underbody were lost. So in this, from this clustering tree analysis, we have seen that rear end panel and underbody were lost. After adjusting the variation of the rear end panel, decreased significantly of each dimension, decreasing about 2 mm. So after adjusting the rear end panel, the dimensional decreasing was about 2 mm. Conclusion. This paper provides a systematical diagnostic and decision support approach driven by variation pattern identification. Moreover, variation level is expressed by variance. A diagnostic tree is used to carry out the variation pattern matching and verification. Fixture and welding information is considered in the fixture fault mode based diagnostic methods. So these are my reference article. In my first paper, I have reviewed about the data mining applications of sheet metal assembly, and the second article was describing the concepts of data mining and clustering process and cluster tree algorithms. In my third article, I was briefly uh, discussing about the implementation of clustering process in sheet metal assembly. In the fourth article describing about the implementation of cluster tree process. And the final article, a new method has to implement for fixing the welding and fixture problems where while attaching the sheet metal to the body we use fixtures or welding equipment. That's all. Thank you and thanks for watching this video. Thank you.